I'm going to hit number 7. This was the equation that you would refer to, and rearranging that to be this is kind of helpful for. Okay, so it's pretty definitive to figure out if you have a high or low electric potential difference, looking at the comparison of crowdedness in number 7. Like, oh, those crowded and those aren't, has a high electric potential difference. To figure out how big the shock is, that's a little harder to determine. Okay, so looking at okay, looking at these 3. And this one has a large electric potential difference, crowded, not crowded. And so this is high. There's a lot of room for electrons to jump over here. So a lot of electrons will. So you got a lot of electrons being transferred, meaning this shock is going to be big. You okay with that? Okay. This one, they're motivated. There's a high electric potential difference, but there's just not that many electrons to begin with to be able to make the jump. Okay, this is the same. That picture there is a good representation of the Van der Graaf generator. Okay, this would be the Van der Graaf generator would be the little circle. I would be the big circle. So they're really motivated, but because there's a limited supply of electrons on here, it's not going to be that powerful of a shock. Okay, and on this one, they're highly motivated, but there's not that much room for the electrons to go, so it's not going to be that big of a shock. Okay. This 4th one, it's kind of like, it's kind of in the middle. Kind of in the middle, yeah. And if they're motivated, yes. Yep. Good with that. Okay. All right. So you got a review worksheet due on Monday, test on Tuesday. I would highly recommend doing this as you work on studying. Come up with a chart of your measurements, variable, unit, and abbreviation. Okay, then look at the top equations on the review worksheet and identify all of the variables. So what do I mean by that? So you're looking at the equation sheet and you're like, man, I see Q all over the place. That's a variable. The measurement that it represents is charge. The unit that charge is measured in is coulombs. Abbreviation of that is a capital C, sometimes seen as microcoulombs. And then just go through the rest of the variables and list those out. There's very few things in here I tell you to memorize. This is one of them. It is essential that you know what the variable and the units are that go with that. Okay. So, and this is a weird unit, like, meters per second. Most people are like, okay, that sounds kind of like a speed and velocity. Okay. Like that doesn't require a whole lot of like effort to learn that. This is just new. It's completely something you haven't been exposed to. Electric fields, electric potential. It's weird stuff. Okay. So creating that chart would be beneficial. All right. What do you think of that question? Okay. This is styrofoam. Insulator or a conductor? Insulator. So will I be protected? Will I be shielded if I keep this insulator between me and the Van de Graaff generator? Will it protect me from being shocked? Yeah. Did it protect me from getting shocked? No. Do you guys see that? Okay. Are you safe in your car from lightning? You are, but it's not because of your tires. Okay. So let's say a thunderstorm rolls in, and you're like, oh no. Like, oh, it's okay. I've got some tires. I stack my tires up in a tower. I stand on my tower and like, haha, I'm safe. Fun fact, air it's a pretty good insulator. So lightning just went through, a mile or two of air, and it looks at your little measly stack of tires. It's like scoffs at it, like, "Are you kidding me?" Wham! Just boom, like you're a crispy critter. Okay, you are safe though, not because of your tires, but because your car has a metal frame. Where does charge on a conductor reside? Where does it live if it's charged? On the outside. The inside of a conductor has an electric field of 0, always in static electricity. You're safe because your frame of your car is metal. So let's say your car doesn't have metal siding, it has fiberglass siding, which are most cars. You're still safe because the frame of your car is metal. Okay, this effect is known as shielding, or sometimes you might have heard Faraday's cage. Same idea. Okay, so here is a picture of the world's largest Van de Graaff generator. We're going to say this is a 6-foot tall man. Those are huge. This would probably hospitalize you. maybe not kill you, but you probably not remember being struck. Like it's, yeah. Okay, but he is perfectly safe in this metal bird cage because the charge goes to the outside. The electric field in the conductor is 0. Okay, so a popular question is, what happens if you touch the cage? So prior to seeing this demonstration, like I've been there, I would not have advised it. But in the act, they grab the cage and they're fine. They are on the outside, but my thought is the electrons would rather go through the metal. It's a better conductor than your skin to get to the ground. That's what they're going for ultimately, is to find to the ground. And so when they grabbed it, they're okay. All right. So some applications of this shielding. So in case you ever find yourself in some kind of like crazy video game type gauntlet obstacle course and there's this Tesla coil that's like zapping people, you can get in some like chicken wire and you'll be fine. Like, so a little more practical applications. Coaxial cable, stuff that you like send, you hook up to TVs and stuff to send signals, has this wire mesh around the outside. Electricity does not pass through that. That is solely to protect the wire carrying the signal from any extraneous electric fields, like interference or anything like that. Okay. An electric guitar, the cavities that holds the pickup are lined with metal, so the net electric field is 0. If you've ever received computer components or circuit boards in the mail, a lot of times they'll be wrapped in this plasticky metal envelope. The whole point of that is to protect that from being shocked, any type of static charge, any type of electric field. It's totally shielded from. Cool with that?
You can almost feel the tension.
So we're fabricating lightning.
I'm being hit by lightning. My hands are buzzing. Hey! All now doing stuff to a car. I've got error up on the dashboard. Handbrake light flashing.
Okay. So he's not dead. It's a good thing. Like, any questions on that one? What are planes made out of? Metal. Think that was an accident? But yet the plane still flies. The lights still blink. Nothing's wrong, other than you probably need to change your pants afterwards because of the thunderclap. Yep, that was pretty loud.
So
there you go.
the lightning strikes the airplane, the electrons are wanting to go like
Mm-hmm. To the ground. The plane happened to get in the way, and it's actually more attractive because it's easier to go around the metal around than it is through the air because it's a conductor, but it's going to the ground ultimately. Like the airplane would not have satisfied the crowdedness of the electrons. With that, okay, this is a little less practical but cool. So Tesla coils, that's what they're standing on. It's a different variation. It shoots out lightning, but it's not. They're just different. But these guys are in chainmail, like suits of armor, knights. Cool. And they're just safe. So this is this next thing beyond the scope of this class, but it's still cool. So Tesla coils, they create lightning with a whole different reasoning, but there's a certain frequency that you get electrons going, and so the lightning won't be like a, but it'll be like a bzzz, it'd make a buzzing sound. If you change the frequency of the Tesla coil, you can make the lightning buzz a different tone, like bzzz versus bzzz. And if you can get it right, you can actually make music. So those notes are coming from the buzzing lightning bolts. Like they're playing it on their instruments, but they have it rigged to the Tesla coils to play that note using the lightning. So the sound's coming from the lightning. Good at that. Okay. Last little point, we kind of touched on this when we had the lightning coming from your fingertips. Charge congregates at points, and so that's why I had to do that versus like a fist or something. Go with that. All right.